Hi everyone, today we are going to do some text processing using nltk-python package. So first you need to make sure you have at least Python 3.7 installed. So let's check that, Python 3 version. Okay, now let's install nltk package. So type 3, install nltk. Great. Now let's start with basic text processing, which is tokenization. This is the text we are going to work with. It's taken from the back of the book, The Outcast. So tokenization is used to split paragraph and sentences into smaller units. This way you can work with smaller pieces of text that are still meaningful even outside of the context of the rest of the text. There are two types of tokenization. We can tokenize paragraph either by words or by sentences. So let's import the relevant libraries from nltk. So from nltk, okay, we need sentence, tokenize, and word tokenize. Okay. In order to use nltk tokenization libraries, we have to download the Pang module. So let's import nltk and download. Okay. Now we can split our text into sentences by send, tokenize, text. Let's just run this first. Okay. And you get a list of all the sentences. You could also split up the text by words. So word, tokenize, text. Okay, you can see that the list contains all the words from the text, including stop words and punctuation marks. We can use the regex tokenizer to tokenize the text without punctuation marks. So let's do that from nltk tokenize. Regular expression, tokenizer, and tokenizer is going to be regex tokenizer, and it's going to be r/w plus. Okay, that will give us all the words that have at least one character. So let's use it on our text. Tokenizer, tokenize text. Okay, great. We can also use it for only capitalized words. So we can define a tokenizer that will be all the words that start with capital word, letter. Okay. Tokenizer, tokenize text. Let's see. Okay, great. So now let's move on to stop words. Most of the time, we will prefer to ignore stop words when dealing with text, since they don't add a lot of meaning to it. So let's remove the stop words from our text. First, we need to download the stop words module. So nltk download stop words, and we have to import the relevant library. Paste, import stop words. Okay. So our text is the same as before. Now let's tokenize our text by words and store the results. Words in text. And just like before, word tokenize text. The next step is to get the stop words in English. So English stop words, stop words. Okay. Now let's filter out the stop words from our text. So filtered words in text is going to be every word or word in words text if word casefold is not in English stop words. Okay, let's see the result. Filter text in words. Okay, great. We could also use lower function instead of casefold, but casefold is much stronger and can find more matches when comparing two strings. You can see the supported languages in NLTK by stopwords dot fields. They have languages like Arabic, Hebrew, Spanish, and more. Let's move on to stemming. Stemming is the process of reducing a word to its stem. For example, the words driver, driving, and drives have the same root word drive. Stemming helps you to get the basic meaning of the word. It will reduce your dictionary size and will make your training data more dense. That will help machine learning models to work better. So let's do this. We will start with Porter stemmer. So from nltk stem import Porter stemmer. Now let's create the stemmer. Stemmer is port stemmer. Okay. We will take the first sentence of our text for stemming. Okay. And let's tokenize the text and stem the words. So let's tokenize first. Words are word, just like before. Word tokenize text. And let's stem the words. So stemmed words is stemmer dot stem word for every word in words. Let's now print the results. Stem words. Okay, as you can see, some of the words remain the same, but some did change, like power instead of powerful, and so on. Another stemmer is the snowball, also known as Porter 2. It's a better version of the Porter stemmer. So let's try it from nltk stem snowball import. Okay. Right. From. Okay. The stemmer, so snow stemmer is the snowball stemmer in language English. Okay. Now let's get the stem words. So stem words is snow stemmer stem, every word that in words. Let's print the results. Stem words. Okay, great. This is a little bit different from before. Okay. You could also customize your own stemmer using the regular expression stemmer. Let's import nltk stem import regular expression stemmer, and let's set the stemmer to $, able, ing, with minimum of 4 letters. Okay, now let's run a few examples. So regex stemmer stem the word available. Okay. Oh, we forgot here another character. Oh, okay. And regex stemmer stem the word bless. Right. As you can see, it returns bless with only one S at the end. And another one, stem the word has. Here it didn't delete S since the length of the word is only 3. Okay. All right. Now, there are 2 possible ways where stemming process can go wrong. The first is understemming, which happens when 2 related words should be reduced to the same stem but are not. This is a false negative. The second is overstemming, which happens when 2 unrelated words are reduced to the same stem, even though they shouldn't be. This is a false positive. So we have to be very careful when choosing a stemming algorithm. Okay, moving on to lemmatization. Lemmatization is similar to stemming in the sense of reducing words to their core meaning, but it will give you a complete word that makes sense of its own. So, for example, the word ate, I ate an apple, will be lemmatized into eat, I eat apple, and this word is called lemma. Let's try it. First, we need to download WordNet. So nltk, download WordNet, and let's import nltk stem, import WordNet lemmatizer. Okay, now let's set the lemmatizer. WordNet lemmatizer. Okay. Now let's lemmatize our text. So lemmatize words. Okay, lemmatizer, lemmatize each word for all the words in words. Okay, let's print the result. We can also set the part of speech tag, and then the lemmatization results could be different. The default POS is noun. So if you write lemmatizer dot lemmatize better, for example, the lemma will be the same. But if you specifically set the part of speech as adjective, you will get something entirely different. So let's copy that and change the POS to adjective. Okay, as you can see, it gives the word good. Okay, in the next video, we will learn how to get the part of speech for each word in a text. This way, we can tag our words before lemmatizing them to avoid mixing up homographs or words that are spelled the same but have different meanings and can be different parts of speech.